This is the 2014 AB FRQ question number 2. So what do they give us? They give us a function, and that's this funky little thing. And there's another function, y equals constant. So you have region R. So I can color this in real quickly. So this is what we're going to, part A, we're going to rotate this. And they give us the line y equals -2. So there it is down there. Now you should be able to see that we have a hollow portion. Let me draw these lines. So we're going to go from between those 2 points. We're going to revolve this thing around y equals -2. So it's going to produce hollow part. So this is the part will be solid. All this in between will be hollow. So we need to take the volume of the whole thing and subtract the hollow part. And so the next thing we need are these intersection points. I call them A and B. And to find that, you need to set the graphs equal to each other. So I'm going to say f of x. Actually, let me do this. I'm going to let y1 equal f of x. So in my graphing calculator, I'm going to make y1 the function that's given. Okay, y2 I'm going to make 4, but that's such an easy function. I'm just going to leave that as is. So f of x equals 4. So here's the line y equals 4, and here's f of x. I want to find where they equal each other. So on my calculator, I graph both of those. And when I graph, I get this function. Now, if you want to zoom in to get a tighter look at this region, we can do that. So we can go from -1 to what? To 3 on the x, and 0 to 5 on the y. So I'm going to go from -1 to 3 on the x. On the y, I believe we said 0 to 5. So it'll give us a tighter view. We need that intersection point and that one. So let me do second calc 5. And I want the one to the left there. So that's my first curve, that's my second curve, bam. So now, this is very interesting. This is why calculators aren't perfect. They use Taylor series and other things to approximate. And this number is actually should be 0. It's actually an error. The calculator's making a mistake. Because 10 to the -7 power, that's like 0.000007195. If you round that off, that's essentially 0. But that is 0. Calculator messed up. Okay? So let me second calc, and let me do an intersection. This time it's the one over here, so when I guess, that's my first curve, that's my second curve, my guess is about 2, because here's 2, so I'm going to enter 2 for my guess. And there it is, 2.3. So the intersection points are 0 and 2.3. At x equals 0 and 2.3. So if this were a test or a quiz, that would be your first point. And that's your second point. So we found our points of intersection. Now we're going to, for part A, we're going to add up. So the volume for part A, we're going to add up all the disks. And let me draw one of the disks. I guess it didn't like that. Not. Okay, it's going to be one of those days. There we go. Woo! So if you see, we're starting here, our revolution, we're rotating around this line here. So as I do that, I produce these disks. Now let me fill these with a color. I think yellow. Oh, that's the wrong one. Let me start with that. Fill with yellow. So there is our disks. Now, as you can see, as I go across, they're all the same size, because that farther one is always constantly 4. So that's what it's going to look like. Our radius for that, always goes from the axis rotation to the furthest graph. Okay, I'm going to call this one R1. So what's the area of that circle? Pi r squared. I'm going to say R1 squared, and I'm going to add them up. The first one is going to be, didn't want to do that. The first one is at 0, and we're going to add them all the way across so we get to B, which is 2.3. Now, the reason I didn't label these A and B, because they're such simple numbers, it's just as easy to use 0 and 2.3. So I'm going to add them all up from 0 to 2.3, and the thickness, left and right, the thickness as you move left and right, x changes, it's a dx. Then I'm going to subtract the smaller circles, and so it's still from 0 to 2.3. I'm going to have an R2 squared. The thickness is dx, but what is R2? So R2, let me copy in or duplicate this. So I'm going to have a smaller one. There's the hollow part on the inside. So as you can see, hopefully, that on the inside, all of this part, the function goes from here to this function, which is f of x. So even if I have it over here, it's still f of x and -2. Oh, I haven't found R1 yet. Let me do that for you. So here's another thing you don't have to do. I'm going to let y1 equal f of x, because that's what I stored in my calculator as. So R1 is big Y minus small y. Well, the bigger Y is right here, 4, and the smaller y is right here, it's -2. So it's going to be 4 minus -2, which is 6. So in my formula here, 0 to 2.3, R1 is going to be 6 squared dx. Now I need to figure out R2. So R2, it's going to go from the axis rotation to my graph, which is closest. That's going to be R2. And my R2 is going to be big Y minus small y. But big Y is f of x. And my little y is here, which is -2, so it's going to be minus -2. So which is f of x plus 2. But my f of x is stored as y1. So right here, you could put y1 or f of x plus 2. That's actually y1, so in your calculator, it's going to be y1. So let's go to my calculator and plug all these in. So go to my home screen. So I'm going to get pi. Did I do the pi here? Yeah, I did. Pi, I'm going to integrate math 9 from 0 to 2.3. And my first one was 6 squared. R was 6. Now, the hollow part I need to subtract. So I'm going to subtract pi. I'm going to integrate, so I'm going to do math 9. And this is also 0 to 2.3. This time, the function was y1 plus 2. y1 plus 2. So I'm going to parenthesize, go to my y1 plus 2, and the parentheses. That's going to be my second function, and it should be squared. It's pi r squared. So let me square that, and that's respect to x. And hopefully it gets me my answer. Bam, 98.867 or 868. I forgot the square there. Whoa. So that's going to be, try it again. I put a squiggly because it's approximately. It's 868, or if you truncate, You could do 98.867. So you could do either answer. So how would I probably score this? I'd probably give you 1 point for that R, 1 point for that R, and 1 point total for those two together for having the integral, the pi, 0 to 2.3. So I'd probably have 1, 1, 1, 1, 1. Maybe on the whole test, if you get all these right, you'll get a bonus point. And then the final answer would give you another point. Okay, so now these R's, you didn't have to rewrite these because you've already defined those up here. So these are one and the same. So you could have left it like that, okay? So that's part A. Now let's look at part B. I'm going to erase a bunch of this stuff. Give me some room. Didn't want to erase that much. Let me see. I might just have to create a new box. You can fast forward through all this stuff. Okay, so part B, we want a cross section. It's perpendicular to the x-axis. What does all that mean? I will explain. I can get rid of a lot of this stuff actually. So here's the x-axis. So perpendicular is this way. So it tells you the base of the solid is perpendicular to x-axis, isosceles right triangle. So it's going to lay down, that's the base. That's the bottom of the triangle. It's going to build out of it. So this is the base. We'll call it B. And I get a triangle out of that. It's going to look kind of like that. But the right, they tell you with a leg in R. So this is a leg, that's a leg, this is the hypotenuse. So it looks like this, where this is the base, that corresponds to that base, and this height is equal to the base because it's isosceles right triangle, so that's base. So the area is going to be 1/2 base times height, which is the base squared. So for part B, I want the volume. You're going to have to add up all of the discs, or excuse me, all of the triangles, the volume of the triangles, starting at 0, ending at 2.3. And the volume of each one, we just calculated, is 1/2 b squared times the thickness, which is dx. But what is b? We'll define b as big Y, which is 4, minus small y, which is f of x. So here we go. It's 1/2 4 minus f of x squared dx. And then we're just going to put that in our calculator, but we know f of x is y1. So let's do this. Back to the calculator. So I'm going to do 0.5 for 1/2. And I'm going to math 9, integrate 0 to 2.3 again. It's going to be b squared, which is, okay, I didn't write down, but it's 4 minus y1. So big Y, parentheses, 4 minus small y was y1. And I'm going to square that, dx. 3.573 or 3.574. 3.573 if you truncate, or 3.574 if you round off. Again, probably 1 point for the constant and that, 1 point for the integrand, and 1 point for the answer. That's Seems how the breakdown would be. I don't know where I'd give you any other points. Again, when I say b squared, technically I mean this squared. So b would have to be defined somewhere to get that point. Okay, now let's go to part C. Let me erase all this stuff. Ooh, didn't want to do that. I don't know if this is going to work. Is it? Okay, it worked. Oops. Okay, part C, that's the part that you have to think a little bit. I'm going to sneeze. Excuse me. Oh, excuse me. So you just got to read and think, okay? So it says a vertical line, x equals k, divides R into two regions of equal areas. So somewhere, there's going to be a vertical line, x equals k. So we know at this point, the value of x is going to be k. So that's k. And this is the line x equals k. And it's going to produce two regions of equal area. I know the area there is equal to the area there. So what I want to do for part C is do A1 equals A2. You do not have to write this down. I did that just so you can see what we're doing. The area 1, we're going to add up all the rectangles starting at 0 and ending at k. So 0 to k. And the area is the height times the width. It's going to be big Y, 4 minus f of x, times the width of each rectangle, which is dx. And that equals the area 2, which we start at k and end at 2.3, because we already found that was 2.3. So we're going to add up the rectangles from k to 2.3. And the height is still the same. And the width is the same. So we added up the rectangles from 0 to k, and then from k to 2.3, and we just set those equal to each other. And so that's what's going on. And that is my final answer for that. Now, as a side note, and I mentioned this in class, instead of doing that, you could do this. That's not working. It's not letting me copy and paste. Whoops. Let me copy. I'll paste it up here and then slide it down because it doesn't like me pasting it. Whoa, that's no bueno. And I can't bring it to the front, so I am sad. I'm just going to copy all this down. So I have the other option of taking area 1 and making it 1/2 the whole thing. Because if that equal to that, then this will equal the whole thing. So instead, I could just make this equal to half the whole thing. The whole thing is from 0 to 2.3. And I'm just giving you another option. I wouldn't have done it this way, but it's another valid option. So that is part C, and I'm done.